picture, and that makes this really hard to understand. All right, so 2 blocks are pushed along the horizontal surface. One's a 2 kilogram and one's a 3 kilogram. And it's kind of a 50-50. I'm pretty sure that the 2 kilogram is first and the 3 kilogram is second based on the way he wrote the problem. And since he didn't give us the picture, we're gonna do it one way, and then if it doesn't work out, we'll know the blocks are flipped. It's really annoying that he didn't give us a picture. All right. So these guys are going to move as a system, aren't they? This is starting to be the theme. You have to think of these as a system. Hey guys, yeah, in the back. All right, so look, this is a 5 kilogram system, and we know the force acting on it is 20 newtons. So right away, we can figure out the acceleration of the system if we needed to, but that's not what they're asking us. They're asking us forces. So we just have that back in our mind in case we need to know the acceleration later, right? Because a lot of times these problems start with this and then they build on it. All right, so let's do a free body diagram. mg, normal force, okay, and object 2 has the force acting on it because somebody is pushing here. Remember, it's a 50-50 choice. We don't know which way they did it. It'd be nice if you'd given us a picture. All right, so that's my force applied. So this is my 2 kilogram guy. And my 3 kilogram guy looks like this. By the way, there's a force missing here, but we'll talk about it in a second. And my 3 kilogram guy has its weight, which is a little bit bigger, so a longer vector, and a normal supporting force. And now it's got the force of block 2 on it. All right, so this is a force applied. This is the force of block 2 on 3. And by the way, it exerts an equal but opposite force back onto block 3. So that's force 3 on 2. Okay? So far, so good? Okay. So some of the forces. So we're worried about the force that the 2 kilogram block exerts on the 3 kilogram block, correct? So that's 2 onto 3. We're worrying about this. All right. All right, so the first thing I'm going to figure out is what's the acceleration of the system. I like to figure out what the acceleration of the system. So sum of the forces on the system is equal to mass times acceleration on the system. The mass of the system is 5 kilograms, all right? Mass of the system is 5 kilograms. I don't know the acceleration. And the total force acting on the system in the x direction, because that's all we care about, is 20 newtons. And so the acceleration of the system is 4 meters per second squared. Cool, cool? Okay, so that means each one of these boxes, it's a system. They have to accelerate at the same rate. So if we come over here to box 2, and it's, right, 2 on, I'm sorry, box 3, because we want to know the force that box 2 exerts on 3, that's the only force that's going to move box 3. Nothing else is moving it. And I know that box has to move at 4 meters per second squared. So the sum of the forces on box 3 equals mass times acceleration in the x direction. There's only one force. I don't know what it is, but I do know that the box has 3 kilograms and it's moving at 4 meters per second squared. Yes? So the force would be 12 newtons. And we come up here and he says, no, it's 8 newtons. And when we see that, they're flipped, exactly. And so then you have to do, and I'm just pointing out, that's how you know. You're like, oh, look, he drew the boxes in the other direction. Yeah. Got it? Yeah. What does it start with, though? How do you know? It starts with figuring out the acceleration. Now, I would never give you a problem like this without a drawing.